welcome to a new episode of Coding Coffee. This is where I share my experience as a programmer and try to offer it as tutorials so you can tackle some of your own projects as well. First, a small different note. It's actually today, it's Taxonomy Recognition Day. It is the birthday of Carl Linnaeus, and so this moment has been chosen to actually, reflect a little bit about what is taxonomy. Of course, taxonomy is not just about recognizing plants, animals, microbia, any living organism. It's also about classifying them, knowing how they relate to each other. Now, I'm a very poor taxonomist. Officially, I'm not a taxonomist at all. Several of my colleagues actually at my botanic garden are, and they are always there to assist you when you need some living organism recognized, let's say. So this is a moment to celebrate their work. My taxonomy reaches as far as the Coffea family, of course, and anything basically that I could eat. That's just what gets me excited. So here you can see the cherry trees I have planted with my daughters. I really like them. Now the magpies also really love them. They've eaten all the cherries just this week. Amazing. And then I went to my favorite spot in my botanic garden. Today it's Taxonomy Recognition Day, and it's with the hashtag Name It to Save It. Of course, we're here at the coffee plant, so it's about getting to know new species. Now, this is not Coffea arabica or Coffea canifora, also known as robusta. This is actually Coffea laurina, a coffee species that, if I'm not mistaken, was described here in my botanic garden for the first time. Now, I would say eat it to save it. And there was actually a berry. I was coming here hoping to be able to have a first taste of Coffea laurina. But it's not meant to be. Of course, when you're visiting our garden, you're also not meant to pick any fruit that you see growing here. It's, for educational purposes only. Of course, saving what you can eat, that's an easy one. Like coffee, that's why I'm so motivated about working on biodiversity analysis on coffee, seeing how we can improve conditions where the coffees are growing. It's a lot more difficult when it's a plant that you're not able to pronounce or eat, to then, be motivated in protecting it. But every species counts to protect the ecosystems. Everything is connected. So go and find some type of species you don't know yet, you don't know the name. So find a taxonomist. Now, the tutorial that we have actually today is to have a look at the work I'm doing to help save coffee plants, all plants basically. And it is in first instance within the framework of the CSI project that I am leading at my botanic garden together with Victor de Klerk. This is crop source investigation, so it's broader than coffee. Of course, I got involved initially because I was very motivated to be able to directly work on coffee. And what we're doing there is using this atomic analysis, looking into the elements present in crops like magnesium, zinc, aluminium, quantifying them, and this gives us an ability to trace where the crops have come from. So in order to do that, of course, we need to trace all the samples coming to the garden, how we are processing them, how we are analyzing them. You basically have to track everything. To do that in, a forensic way, we need, that's where we headed towards. So what I now will present is the software package using Python Flask as the web app framework, and how I'm using also Python typing to easily describe what kind of information we need to trace. So this is what we're seeing here. So the MACE CSI project, Mice Botanic Garden Crop Source Investigations platform. This allows actually several things. This exact piece of software can be started up by simply going to the RISE package here, which stands for Reproducible Infrastructure as Code and Environments. It has the containers to run the software. It also has the infrastructure as codes that you can find here. And this script allows you to start up a full server and have it operational in minutes. Even if you want to do this kind of analysis on your own custom platform, you could use this as a starting point. For the moment, it's just working on AWS, Amazon services. In the future, maybe I'm able to adapt it to other platforms as well. When this starts up, it will actually give you a few things. It will give you the server running, which we'll get into in a minute. It will also give you a notebooks server to be able to give tutorials. And in the notebook server, you'll be able to see this kind of notebooks here, which I have talked about in previous episodes, if I'm not mistaken, as an environment to do some coding in. And this is just very easy, to show all the steps that you need to do. So actually, you need to have this packages installed, Flask Boto, so that's Flask Blueprint Automated, because we're using a concept within Flask called blueprints, which groups data and views together. And I have actually taken this a step further by automating this whole project, because usually you had to define your models and your forms, the forms that would be displayed on the front end, and you would have to do this work twice over. So actually, we'll get into this in a short while. I've kind of combined this by using Python typing. And then we have the Bull Stack, which is a blueprint-driven full stack Flask application. So those two packages is all you need. I mean, they take care of all the dependencies, and then you're good to go. So let's see how this can work. I will now just to have a clean start, I will restart the kernel. So this I can run this, but it should already be installed actually. So this should be quick. And then here we're getting really just now to the code. You see, we have the Flask Boto, we have an auto blueprint, a data class, and a relationship. Now the data class is important because it's basically telling the platform this is the relevant class. This is on which we want to gather the information. So then to define the platform is basically saying, well, we're showing here an example using two blueprints, taxonomy, because it's taxonomy recognition day. So we're having a genus, then we're having here a species, and we're having a crop, because we are interested in having crop specific information. So that should also be in our system. And then we have the CSI functionality, which then has a project. We might be analyzing a coffee coming from Ethiopia or something like this. What's the provenance? Where do they claim it's coming from? What kind of samples do we need to analyze? So that would be linked to project IDs, species IDs, provenance IDs. And this last part isn't fully developed yet. It's just show how you could have additional views on this data, because a lot of it will be automated, which we'll just show now in a second. So then we have the Bull Stack to be able to have this full stack environment started up. So we want to use this taxonomy and the CSI. So let's rerun this. It should still show the second one. The first one was seeing that our dependencies were installed, so it ran correctly. It is giving us a warning, and that is that interactive defined blueprints might not have functional relationships. Now, in a normal setting, when you're really setting up your platform, you don't do this interactively. So this would be installed on a server script, and then everything works as intended, which is genus is defined before species. So the genus underscore ID, and this is an integer, actually means that this, if genus is already known, which it is because it is defined first, it will automatically link the species to the genus. And for crop, species is already known, so it will actually link that to the species. Now, what happens in an interactive session, when you're asking the annotated data classes on this class, it ranks them alphabetically. Now, in the fully operational version, when you have this sitting saved in a script, it's able to ask the script file and see, well, genus was defined before, so this is already known, so I can link these two things together. It can also be linked in the other way, which we see here. Species is a relationship. It's set to none, meaning it's a standard relationship. So it's going to expect that there's a species class that is linking back to genus, and everything in the backend is set up correctly. So this is already running in the sense of it's established everything it needs to know to start its web app. It's actually not running yet, which we can check here. I will do it on port 5001. Here we go. So it's not finding that because it's not running. This is previous outputs. Now we'll start this up, and it's saying, okay, this is a development server, do not use in production. This is just to showcase. All right. So now we can renew, and you see we have a fully functional platform. Okay, so let's add a crop. Well, or we should start with a genus. Of course, it wants us to log in because it's a safe environment. So we'll just do this. We'll quickly, this is just a toy example. All right, there we go. Registration succeeded. Now I can go. Well, actually, I then need to log in. All right. It's asking the genus ID. Of course, we haven't defined a genus yet. So let's go to create a genus. Now, of course, I want the coffee genus and, Rubiaceae, which is a mistake. I'll come back to this later. Submit genus. This is actually just showing how bad of a taxonomist I am. I'm, not very good at names. I'm already happy I'm somewhat able to say what the family Coffea belongs to. So now we get this list interface where it's like, oh, we made a mistake. Okay, let's just edit this. Okay, it's actually not Rubiaceae, it's Rubiaceae. And that's updated. Perfect. Okay, now we need to go back to the list view of all our genuses already in the system. Okay, here we go. And we want to add now specific species. Okay, so let's add Arabica. So this is showing it's, it's not really that clean of an interface yet. You can change these things quite easily, actually. We'll indicate that in a second. Now we have Arabica joined. Let's also have Canifora or Robusta, where at the garden we're doing a lot of work. So you can keep adding species if you want to, but you can also ask this list. So now we have Arabica, Canifora. You can now also edit specifically the species in case you made a mistake there. Of course, with Arabica, it's, I'm not likely to make a mistake there. Or the difference with Canifora, also Robusta, of course. So at this point we don't have any crops yet. If we now want to add a crop, it's going to give a little bit of an issue. It still finds the species, so it's linking that. And let's do bourbon. And at this point, it still needs something filled in. There's a lot of small things still to do. Now you see, this is not showing properly, and this is because we're working in this kind of interactive environment. So now, we could also just easily change things. Let's say, we realized, we shouldn't be reinventing the hot water. We shouldn't be having our own, fully independent taxonomy, but we want to link it with GBIF. So let's have a GBIF ID in here, and that should be, we'll make it a string so it doesn't confuse it with an ID. Actually, it's not going to do that. Let's have a full experiment. Let's just also do an ID that it doesn't know. Restart kernel, restart kernel. Okay, so we're in a fresh environment, doing this. Oh, now it is giving a, now it is giving an error. Built-in function ID. Did I make a typo? Did I make a typo? Where did I write? Oh, I wrote here ID. That's just an honest mistake. Let's rerun this. There we go. Now it is running again. This is again showing the output from last time, so this wouldn't work. You need to rerun it. Again, it is working. And however, it's still showing the, need to go directly again to registering, and here we go. Yes, registration completed. So now we can log in. Let's go directly to create species to show you what has changed. Admin. Okay, so now you can see we can add a gbif ID, and it's just showing it. It's not showing it as something linked to the system. It's showing it as an integer. So now you can add the gbif ID and have it linked to the gbif taxonomy backbone. So we touched a lot of things, showing you how this works. This platform that we'll use as the engine for our forensic laboratory, gathering all the data we need to track our samples. This has forensic functionality also in the sense of that everything is tracked, user actions, which user being an ID, of course, the usernames and personal information to be GDPR proof is in a table where we don't have this kind of tracking, of course, which is a separate module, so not this blueprint and forensic enabled way of tracking everything. So then you just have the integers, the IDs of all your users and all the things that they are doing, and this is a professional setting, so it shouldn't have any person related information. So there's a lot of things to consider when setting up this kind of forensic laboratory and coding. If you're interested in the work we're doing, if you want to help on the lab work or programming work, let us know, of course. It's always good to know for the future as well, who is willing and able to contribute to projects like this. So have a good taxonomy recognition day. Go and find some plants or animals you didn't know before, or at least you didn't know their name. And if you have trouble finding out, there's a lot of apps now also to help you identify. But if they're stuck, just reach out to us. Not me, I'm not a good taxonomist, but one of my colleagues will definitely be able to help you. So thanks for following this episode and hope to see you on a next one.